Today, we're diving into a massive, and I mean absolutely massive, paradigm shift in how we build artificial intelligence systems. If you're building software or really just working with AI in any capacity, your daily workflow is about to completely change. We are officially moving away from treating AI as a simple question and answer machine, and we're heading straight toward building fully autonomous systems.
So let me ask you a question. Are you still manually prompting your coding agents? Let's be real here. Whether you're a total beginner writing your very first script or a seasoned professional, you've probably felt the deep frustration of babysitting your AI. You type a prompt, it spits out code with a bug, you copy the error message, paste it back in, rewrite the prompt to try and fix it, and you do this over and over and over again. It is completely exhausting, right?
Well, Boris Cherny, he's the creator of Claude Code, recently summed up this shift perfectly. He said, I don't prompt Claude anymore. My job is to write loops. Instead of doing the back and forth dance, he builds systems that figure out what to do and prompt the AI for him. And this perfectly highlights the stark difference between the tedious manual prompting of today versus the autonomous loop engineering of tomorrow.
Okay, let's map out our journey for today. First, beyond basic prompting. 2, what is loop engineering? 3, open versus closed loop AI. 4, the anatomy of a loop. 5, AI loops in action. And finally, 6, the future of AI coding.
All right, let's jump right into section 1, beyond basic AI prompting. Right now, we're basically treating early AI tools like fancy autocomplete. The AI is just a one-shot generator. It takes a guess, and then the human developer is left doing all the heavy lifting. You're the one gathering the context, you're running the tests, you're interpreting why it failed, and then manually reprompting when it inevitably makes a mistake. You're automating the work. Actually, scratch that. You're not automating the work at all. You've just become a full-time editor for a very fast, very confident intern. Which brings us to section 2. What is loop engineering? Loop engineering is the practice of designing workflows where an AI repeatedly plans, acts, observes feedback, and adjusts its approach until a task is actually complete. Instead of you sitting inside the loop endlessly typing out prompts, you write a small program that does all of that for you. Your job moves up an entire level. You're no longer writing the code, you are writing the system that writes the code. It is a total game changer. So how does this actually work structurally? Let's look at section 3, open versus closed loop AI. This brilliantly illustrates the difference. Open loop AI is execution without feedback. It's essentially blind. It executes a decision based on its pre-trained objectives, but it never stops to verify the real-world outcome. Closed loop AI, however, is built on continuous evaluation and adaptation. It takes an action, measures the effects, reads the errors, and adapts its behavior through real-time feedback. And there's a very specific reason open loops fail. Cognitive alignment science highlights a fascinating concept called cognitive drift. Basically, this is a silent, growing divergence between what the AI is doing and what the human actually intended. Open loop systems fail because the real world is constantly changing, but the AI can't reevaluate its behavior in light of those changes. So misalignment isn't just a possibility in an open loop. Scientifically speaking, it is structurally inevitable because there's absolutely no feedback mechanism to correct that drift. Moving on to section 4, the anatomy of a loop. Let's see exactly how these are built from the ground up. A core loop progresses through 5 distinct stages. First, intent, you have to define the target outcome. Next is context, where the agent gathers the necessary code and documentation. Then comes action, where it actually edits files or runs commands. Fourth is observation. This is where it captures the test results or the compiler errors. And finally, adjustment, where the agent updates its plan based on that actual evidence and repeats the cycle. It's a continuous loop from target outcome to self-repair. Now, to build that cycle in a real production environment, you need to assemble 6 specific components. You need a trigger, like a schedule or an automated webhook, just to kick the loop off. You need isolation, so multiple agents don't accidentally overwrite each other's work. You need written down context, so the AI knows the rules of the road for your project. Connections to your tools, like your database or CI server. You also need a second agent checker because, let's face it, a model grading its own work will pass almost everything. And finally, state on disk. You have to save the progress outside the chat window because the model's memory resets. The really beautiful thing here, most of these components now ship directly inside modern coding tools. Section 5. AI loops in action. Let's bring all this abstract theory into concrete reality. Let's look at a fully automated PR babysitter loop. At minute 0, a trigger initiates the loop automatically. By minute 1, it scopes out any open pull requests. At 5 minutes, it takes action to fix continuous integration errors or rebase the code. And by minute 10, it checks the stop condition to see if the build is green. Think about that. Instead of developers wasting hours fixing broken builds, the loop handles that routine ops work autonomously. You just get to return to completely merged pull requests. But to do that safely, you need a rock-solid contract. Commands inside coding agents function on 4 strict rules. First, you must specify the end state, exactly what you want. Second, the evidence, how to mathematically prove it, like getting an exit code of 0. Third, the constraints, the rules it absolutely cannot break, like don't break the authentication system. And crucially, a budget, for example, a maximum of 20 turns. If you leave any of these vague, the AI will just take the easiest shortcut it can find and redefine success just so it can stop early. All right, let's zoom back out for our final section. Section 6, the future of AI coding.
6. So why are we looking at the number 6? Well, because the fundamental economics of AI are changing. Your budget line is no longer measured in individual tokens. It's measured in iterations. A cheaper AI model that struggles and has to loop around 6 times to fix its own mistakes, that actually ends up costing you 6 times as much as a smarter model that gets it right on the first try. In this new world, you are optimizing the loop itself, not just the prompt.
But look, we have to be realistic here. Unintended loops have some very predictable failure modes. They can end up thrashing without ever actually converging on a solution. They can overfit to tests, meaning they pass the automated check but totally fail the actual product requirement. They suffer from context drift if they rely on stale assumptions. And worst of all, if they are given unsafe autonomy without the right permission dates, they can cause real damage. This is exactly why the human engineer designing the loop matters far more today than they ever did before. Alignment is a process, not a feature. You cannot guarantee an AI will do what you want just by training it perfectly one time up front. True alignment requires continuous, auditable, and regenerative feedback embedded directly into the system's daily workflow. It has to be a living, breathing loop. So, is your AI building technical debt, or is it building the perfect loop? Because if you aren't engineering loops yet, it might just be doing the former.